Hi guys, today we're going to keep going on 9495 and we're talking about explicit versus recursive equations. I'm pretty sure the first day of notes that I gave you on 9495, I don't have them on this sheet, but I'm pretty sure I told you the definition and I mentioned explicit and recursive and was like, we'll get to them later. Well, guess what? Now is later. So we are doing explicit versus recursive. Let me try again. This is a mess. Explicit versus recursive equations. And this deals with sequences. So I'm going to write sequences next to it. So sequences is not the sum, it's just the list of all the numbers. Okay, so I'm going to do an example that uses both explicit and recursive so we can kind of remind ourselves what I told you the definition of them were. And we can kind of see the differences pretty closely. So we are going to find the a sub 6 and the a sub 100 term of a sequence where we're going to do two things. And these are not the same sequence. These are two separate sequences. The first one is going to be an explicit function, and the second one's going to be recursive. So it's explicit or an explicit equation that I'm going to give you is going to say a sub n equals n squared minus 1. Okay? A sub n equals n squared minus 1. This means that I can plug any number. These are the same numbers. I've got n and I have n. So any number that I plug in would be my a sub 6 term or a sub 100 term. I would just plug that same number in over there. Now we will go one at a time up to 6, and then I'll show you it's easy to just plug in for 100. So a sub 1 is going to be 1 squared minus 1. That's going to be 0. A sub 2 is going to be 2 squared minus 1, which is going to be 3. A sub 3 will be 3 squared minus 1, 8. A sub 4, 4 squared minus 1 equals 15. A sub 5 equals 5 squared minus 1 equals 24. And then a sub 6 equals 6 squared minus 1 equals 35. Now that was kind of painful, and we just did 6 of them, right? So imagine if we had to go all the way to 100. Luckily, we don't. We can just do a sub 100 is equal to 100 squared minus 1. That's easy. I can throw 100 squared in the calculator minus 1. I believe that's 9,999. Okay, so I got these two terms right here. 35, 999, 9999, whatever. And so that's what the question asked. Find a sub 6, a sub 100. I found those two, moving on. Okay, now I could give you a recursive equation. A recursive equation that is not related to the explicit one. They're two totally separate ones. This is just a recursive equation. And so this one, I have to give you a sub 1, or I have to give you something, and then I'm going to say a sub n equals a sub n minus 1 plus 2. In my definition of recursive function, I said you need the term in front of it, or it tells you how it relates to the term in front of it. That's what this a sub n minus 1 is. So if a sub 1 is 1, then a sub n minus 1 is like the term before that. That's why I have to give you one of the terms, because if I just gave you the equation, you wouldn't be able to do anything. So like a sub 1 is already found, it's just 1. But I need that to do a sub 2. So if I do a sub 2, a sub n, well, I'm going to do a sub n minus 1 or 2 minus 1. That's a sub 1. So I have to use the term in front of me in this equation. So I'm going to do 1 plus 2, and that equals 3. Now I use this 3, and to find a sub 3, I'm going to do 3 plus 2. Well, that equals 5. Whoa. To find a sub 4, I'm going to do 5 plus 2. That's equal to 7. A sub 5 is going to be 7 plus 2, which is 9, and then a sub 6 equals 9 plus 2, which is 11. I'm going to highlight that one because that's one that was asked of us to find. Now, The other one we just plugged and chugged and it was all easy, it was all fun and games. This one, not so much. In order to find 100, we need to find out like what the explicit equation would be. So I can find the explicit equation. In this case, is it going to be geometric or arithmetic? Am I adding and subtracting, or am I multiplying or dividing to get to the next term? I'm adding this time. I'm adding 2. Add 2, add 2, add 2, add 2, add 2. So my a sub n would equal a sub 1, which we know is 1, 1 plus n minus 1 times 2. So that's 1 plus 2n minus 2, 2n minus 1. That's your explicit equation. And then I'm just going to plug, I think so. And I'm going to plug in a sub 100. So I'm going to do 2 times 100 minus 1. 2 times 100 is 200. 200 minus 1 is 199. And that is my correct answer. All right. So we move on. Cool. I can keep plugging them in when it's a small amount of numbers, but I'm not doing that up to 100. That's going to take too much time, and I don't have time or patience for that. So instead, we can find the explicit formula. That's going to work. Okay, now we're going to do a few more types of examples. One thing I want to show you first, sometimes we have a hard time with this, like the order of the sequence. So like when I say like, I'm just going to call order of sequence. I don't care what you label this little section. A sub n, we can think of that as like a middle term. A term that's like 1 bigger than that would be a sub n plus 1. Let me make that a little nicer. If I think of 1 bigger than that, it would be a sub n plus 2. And I can keep going. A sub n plus 3, and on and on. If I was going backwards the other way, I'm not adding another term, I'm minusing off. So if I go this way, it becomes a sub n minus 1. And if I go one more, it becomes a sub n minus 2. And then I can go one more, a sub n minus 3. And then I can think of and on, dot, 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 on both sides. So that's how they're related to each other. So like if I have like a sub 1 and I'm talking about like it's a sub n plus 2 term, it means it's 2 more spaces up. So you can kind of visualize what's being talked about, or you can make a little table if that's helpful to you. A little visual is never hurts anybody. All right, now we're going to do a couple examples on how we solve these things, or how we would do kind of problems like this. And so like the first type of problem I could give you would be find the first 4 terms. Find the first 4 terms. And I'm going to give you recursive equations for this. So this first one, I'm going to tell you that a sub 1 equals 3. And I'm going to tell you that a sub n is equal to 2 a sub n minus 1 plus 1. 2 times a sub n plus minus 1 plus 1. So I'm going to replace this term with an actual number each time, multiply it by 2, add 1. So we're going to find the first 4 terms. We know a sub 1 is 3, so I'm just going to list that over here. I'll just pick a different color so you can see kind of the work that's being done. If I do a sub 2, it's going to be 2 times 3 plus 1. 2 times 3 is 7. 7 plus 1 is, 2 times 3 is 6, plus 1 is 7. I got a little ahead of myself there. A sub 3 is going to be 2 times 7 plus 1. Again, you take the 1 in front of it, bring it down. Take the 1 in front of it, bring it down. 2 times 7 is 14. 14 plus 1 is 15. And then a sub 4 is going to be 2 times 15. Again, bring it down, plus 1. 2 times 15 is 30. 30 plus 1 is 31. So those are my first 4 terms. If you want to list them in order, you can go 3, 7, 15, 31, dot, dot, dot. Those are my first 4 terms. Let's do another one. this one, I'm going to give you a sub 1 is 5. I'm going to give you a sub 2 is 8. And I'm going to give you that a sub n, get ready for this, is a sub n minus 1 minus a sub n minus 2 squared. Whoa, we've got two terms. That's why I had to give you two. We're going to replace a sub n minus 1 with a number and a sub 2, or a sub n minus 2 with a number. So we'll have a number minus a number squared. Okay, so this first number that we're going to find is going to be a sub 3. If I'm going to do a sub 3, I'm going to do a sub n minus 1 minus a sub n minus 2. If my n is 3, 3 minus 1, my first term is going to be a sub 2, which will be 8. So it's going to be 8 minus, and then 3 minus 2 is going to be 1. So then I'm going to put 5 in here. So think about, it goes a sub 2 and then it goes a sub 1. So the next one will go a sub 3 and then a sub 2. So we'll see that in a second. And then don't forget it's squared. 8 minus 5 squared is 3. 3 squared is 9. Okay. Now I'm going to do a sub 4. So I'm going to do a sub 3 minus a sub 2 and then square that. A sub 3 we just found is 9. A sub 2 is 8. 9 minus 8 squared. Well, that's just 1, and 1 squared is 1. And then do I have to find another term? Let's just find another term. I don't know what the directions I gave you, but let's just find at least one more. All right, so now I'm going to do a sub 4 and then a sub 3. So a sub 4 was 1 minus a sub 3, which was 9 squared. 1 minus 9 is negative 8. Negative 8 squared is positive 64. So this one's kind of a funny sequence, but that's okay. 5, 8, 1, 9. Nope, I did that wrong. 9 and then 1. And then 64. Don't do that. So it's a funky sequence, but it's still a sequence. I followed the rules. 5, 8, 9, 1, 64. All right, let's get a different kind of problem. So now we are going to find the explicit equation given the recursive equation. So these examples, we are going to find the explicit equation if we are given the recursive equation. All right, so let's see what that looks like. Number 1, I'm going to give you a sub 1 equals 3. I'm going to give you a sub n equals n minus 1 plus 4. So we're replacing that a sub n minus 1 with an actual number in a second. Let me give you a few more directions. So I'm going to ask, is this sequence arithmetic or is it geometric? And then once you figure that out, find the first 5 terms. And then I want us to figure out what the explicit equation is. So I gotta do a couple steps. The reason I'm asking you to do A before B is because we need A in order to find B. So it's not more work, it's just helping us figure out what's going on. So if I'm gonna do part A, first, is it arithmetic or geometric? Maybe finding the first 5 terms will help us determine that. So let's do that. So we know a sub 1 is 3. A sub 2 is going to be 3 plus 4. Well, that's 7. A sub 3 is going to be 7 plus 4, which is 11. A sub 4 is 11 plus 4, which is 15. And then a sub 5 is going to be 15 plus 4, which is 19. So is my change in between these multiplying and dividing or adding and subtracting? Yep, add 4. Plus 4, plus 4, plus 4. So this is an arithmetic, and my D is equal to positive 4. Okay, so we found that. We did all part A. We said if it was arithmetic or geometric. We found the first 5 terms. Now we have to do part B. which means find the explicit equation. So I labeled it as arithmetic because I can go back to my notes earlier, so you can flip through your notebook and remember that the general formula for an arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d. And I'm just going to plug in my pieces. It's going to be a general explicit formula, so I don't have an n. I do know my a sub 1 is 3. Again, I still have n holding the place, and my d is 4. I am going to try and simplify this as much as possible just because it will look nicer. 4n minus 4 can combine your 3 and your negative 4, 4n minus 1. So that's my explicit formula. That's it. Okay, let's do another one. I'm going to go back up to the top of the page now. This is the exact same direction, same find explicit formula, same part A, part B, etc. So we will say example, part A says arithmetic or geometric, find first 5 terms. And then part B says find explicit equation. Now, my sequence for this, or my information I'm going to give you, is going to be a sub 1 equals 64, and a sub n equals 1/2 times a sub n minus 1. I'm going to do part A first, so I'm going to find all of the terms, and then I'll decide if it's arithmetic or geometric. So a sub 1 we already know is 64, that's cool. A sub 2 is going to be 1/2 of 64, which is 32. A sub 3 is 1/2 of 32, which is 16. A sub 4 is 1/2 of 16, which is 8. And I just have to go one more. A sub 5 is 1/2 of 8, which is 4. Is this arithmetic or geometric? Am I adding and subtracting or dividing and multiplying? We are dividing. Divide by 2, divide by 2. So that means it's geometric, and it means that my r is equal to not divide by 2, but times 1/2. This is the way we write it, times 1/2. Okay? Now I have to write my explicit formula. Again, it's good we recognize that it was geometric so that I know it goes into the a sub n equals a sub 1 times r raised to the n minus 1. Usually I have parentheses around r. And this one's actually pretty simple because I'm going to leave it about as basic as it's given to me. So it's going to be 64 times 1/2 raised to the n minus 1. And I'm going to call it a day there. Okay. Now, I've got one more type of problem. If I give you 4 terms, I want us to find the recursive equation. So we have not found the recursive equation. It's a lot more simple than you think. So just kind of like let it be this simple. So this is the last type of examples that we're doing. Find recursive equation. And my first set of numbers is 9, 13, 17, 21. What are you doing each time to get to the next term? You're adding 4, adding 4, adding 4. So, I mean, we can think of it a little bit more complexly and say, okay, my a sub 1 is 9, my d is 4, we know it's arithmetic. But at the end of the day, recursive deals with how does each term relate to the term in front of it. So if I say a sub n is equal to a sub n minus 1, so like what did I do to get from like 9 to 13? I added 4. And that's the same way for all of them. So to get from the term in front of it to the term you're on, you just are going to be plus 4. That's it. And I'm going to write underneath it, add 4 to previous term in case you are still not sure on how we got there. So each time you took the term in front of it and you added 4. That's it. Okay, now let's do a geometric one because I'm trying to give you examples of both types if I can. 81, 27, 9, 3, dot, dot, dot. So those are my first four terms. I would say find the recursive equation. You can label again, a sub 1 is 81. We can label again, r is, okay, how do you get from there to there and there to there and there to there? Divide by 3, so r is 1/3. And we know it's geometric because we're dividing or multiplying, not adding and subtracting. And then again, simply like, what did you do to get from one term to the next? How do we get our a sub n term? Well, we take the term in front of it, our a sub n minus 1, and we multiply it by 1/3. Now I'm going to rewrite that because I think it looks better if I write the 1/3 first, but I'm just showing you that like that was my train of thought is I took the term in front and I was like, what did I do to it each time? And it's multiplied by 1/3. So I'm going to keep that there. And if we want a little kind of spark notes, what you did is you divide previous term by 3. And that's all. So I hope that's enough help on explicit and recursive functions, showing the difference, showing a few examples. Yeah, if you have any questions, let me know. And that is today's lesson. We talked about infinite geometric series and recursive and explicit functions. So have a great rest of your day, guys. Bye.